The sun, our very own star, is a celestial powerhouse. It bathes the Earth in light and warmth. But the sun also emits something else, something invisible and powerful: solar winds. These winds are a constant stream of charged particles, mainly electrons and protons, that flow outward from the sun. They travel at incredible speeds, reaching millions of miles per hour. Solar winds are a fundamental aspect of our solar system. They influence the planets, moons, and even the vast expanse of space between them. Understanding these winds is crucial for comprehending the dynamics of our cosmic neighborhood. They hold clues about the sun's behavior and its impact on Earth. These winds are not just a scientific curiosity, they have real-world implications. Solar winds can disrupt satellites, affect communication systems, and even pose risks to astronauts. Studying them is essential for protecting our technology and ensuring the safety of future space missions. As we delve deeper into the mysteries of solar winds, we gain a greater appreciation for the sun's power and its far-reaching effects. Our journey begins at the sun's corona, the birthplace of these enigmatic winds. The sun's corona, a shimmering halo of plasma, is much hotter than the sun's surface. This intensely heated region is where solar winds originate. The corona's extreme temperatures, reaching millions of degrees, provide the energy needed to accelerate particles to their incredible speeds. The sun's magnetic field also plays a crucial role in the formation of solar winds. Magnetic field lines, like giant loops, extend from the sun's surface into the corona. These lines act as pathways for charged particles to escape the sun's gravity. As charged particles spiral along these magnetic field lines, they gain speed. Eventually, they reach a point where the sun's gravity can no longer hold them. They break free and stream outward into space, forming the solar wind. The sun's magnetic field is dynamic, constantly changing and reconfiguring. These changes affect the speed and direction of solar winds. Understanding the interplay between the corona's heat and the sun's magnetic field is key to predicting the behavior of these powerful winds. Solar winds are not just a blast of empty space. They carry with them a mixture of particles and magnetic fields. This plasma soup is constantly changing in density and speed, influenced by the sun's activity. The primary components of solar winds are electrons and protons, the building blocks of atoms. They also contain smaller amounts of heavier ions, such as helium, and even traces of iron. These particles travel at speeds ranging from 250 to 750 kilometers per second, a staggering pace that allows them to cover vast distances. The speed and density of solar winds are not constant. They vary depending on the region of the sun from which they originate, and the sun's overall activity. During periods of high solar activity, such as solar flares or coronal mass ejections, the speed and density of solar winds can increase dramatically. Understanding the composition and speed of solar winds is crucial for predicting their effects on Earth and other objects in the solar system. It allows us to prepare for potential disruptions to our technology and to study the complex interactions between the sun and its surroundings. Earth is constantly bombarded by solar winds. Fortunately, our planet has a natural defense mechanism, the magnetosphere. This invisible shield, generated by Earth's molten iron core, deflects most of the charged particles carried by solar winds. The magnetosphere acts like a giant bubble, surrounding Earth and protecting us from the full brunt of the sun's energetic particles. When solar winds encounter the magnetosphere, they are deflected around it, much like water flowing around a rock in a stream. However, the interaction between solar winds and the magnetosphere is not always smooth. The magnetosphere is constantly being pushed and pulled by the changing pressure of solar winds. These interactions can create geomagnetic storms, disturbances in Earth's magnetic field that can have noticeable effects. Despite its protective role, the magnetosphere is not completely impenetrable. Some charged particles from solar winds can leak through, particularly at the poles where the magnetic field lines converge. These particles can then interact with Earth's atmosphere, creating stunning auroras. Section 5. The Northern Lights, a dazzling display of solar wind interaction. One of the most visible and awe-inspiring effects of solar winds on Earth is the aurora borealis, also known as the Northern Lights. These shimmering curtains of light, predominantly green but sometimes red, blue, or purple, dance across the night sky in high-latitude regions. Auroras occur when charged particles from solar winds, guided by Earth's magnetic field lines, collide with atoms in the upper atmosphere. These collisions excite the atoms, causing them to release energy in the form of light. The colors of the aurora depend on the type of atom being excited. Green, the most common color, is produced by oxygen atoms. Nitrogen atoms can produce red, blue, or violet hues, adding to the spectacle. The intensity and frequency of auroras are directly related to solar activity. During periods of high solar activity such as solar flares or coronal mass ejections, auroras can become more frequent and vibrant, sometimes extending to lower latitudes. Observing and studying auroras provide valuable insights into the interaction between solar winds, Earth's magnetosphere, and our atmosphere. They offer a glimpse into the dynamic relationship between the sun and our planet. Section 6. Space Weather Forecast, Solar Winds and Their Impact on Technology. Solar winds, while invisible to the naked eye, have a profound impact on our technology-dependent world. The charged particles they carry can disrupt satellites, interfere with communication systems, and even pose risks to power grids. Satellites orbiting high above Earth are particularly vulnerable to solar winds. The high-energy particles can damage sensitive electronics, disrupt onboard computers, and even shorten a satellite's lifespan. These disruptions can affect a wide range of services, from GPS navigation to television broadcasts. Communication systems, especially those that rely on radio waves, can also be affected by solar winds. The charged particles can interfere with radio signals, causing disruptions and outages. This is particularly problematic for long-distance communication, such as transoceanic flights or military operations. Power grids, the backbone of modern society, are also at risk from intense solar storms. The surge of charged particles from solar winds can induce currents in power lines, overloading transformers and causing widespread blackouts. Understanding and predicting space weather, the conditions in space that can affect Earth and our technology, is crucial for mitigating these risks. Space weather forecasting centers around the world monitor solar activity and issue alerts about potential disruptions caused by solar winds. Section 7. Navigating the solar sea space exploration and solar winds. As we venture farther into space, understanding and accounting for solar winds becomes increasingly important. Spacecraft and astronauts are exposed to the full brunt of these charged particles, posing risks to both human health and mission success. Solar winds can damage sensitive electronics on spacecraft, disrupt communication systems, and degrade solar panels, which provide power for long-duration missions. Shielding spacecraft from the harmful effects of solar winds is a major engineering challenge for space exploration. Astronauts too are vulnerable to the radiation carried by solar winds. Exposure to high levels of radiation can increase the risk of cancer and other health problems. Spacecraft designed for human missions must incorporate radiation shielding to protect astronauts during their journeys. Predicting and mitigating the effects of solar winds is crucial for ensuring the safety of astronauts and the success of future space missions. Understanding the behavior of these winds will be essential as we explore the Moon, Mars, and beyond. Section 8. Unlocking the Sun's Secrets, Ongoing Research on Solar Winds. Scientists around the world are constantly studying solar winds to unravel their mysteries and improve our ability to predict their behavior. Advanced spacecraft and ground-based observatories provide a wealth of data, allowing us to study these winds in unprecedented detail. One such mission is NASA's Parker Solar Probe, launched in 2018. This groundbreaking spacecraft is designed to touch the sun, flying closer to our star than any previous mission. The Parker Solar Probe is providing unprecedented insights into the corona, the birthplace of solar winds, and the mechanisms that accelerate these winds to their incredible speeds. Another important mission is the European Space Agency's Solar Orbiter, launched in 2020. This spacecraft is designed to study the sun from a unique perspective, orbiting closer to the sun's poles than any previous mission. The Solar Orbiter is providing valuable data on the sun's magnetic field and its role in generating solar winds. These missions, along with ongoing research using ground-based telescopes and computer simulations, are helping us to unlock the secrets of solar winds. By understanding these winds, we can better protect our technology, safeguard astronauts, and unravel the mysteries of our dynamic sun. Section 9. The Future of Solar Wind Studies, Implications and Discoveries. The study of solar winds is an ongoing endeavor, with far-reaching implications for our understanding of the sun, our solar system, and the universe beyond. As we continue to explore space, our knowledge of solar winds will become increasingly important. Future research on solar winds will focus on improving space weather forecasting, developing more effective shielding for spacecraft and astronauts, and unraveling the mysteries of the sun's magnetic field and its influence on solar winds. The study of solar winds also has implications beyond our own solar system. Many stars, like our sun, emit stellar winds. By studying solar winds, we can gain insights into the behavior of other stars and their potential impact on planets orbiting them. The exploration of solar winds is a journey of discovery, revealing the hidden forces that shape our cosmic neighborhood. As we delve deeper into the mysteries of these winds, we gain a greater appreciation for the sun's power and its profound influence on our world and beyond.